Hello there. Imagine an object made of rubber so that you can stretch it or you can able to twist it in any direction, and you can also able to bend it either upwards or downwards. These type of operations can be studied under the branch of mathematics that is topology. This is the mathematics of continuous deformation. So under the continuous deformation we can able to change a circle to ellipse and an ellipse to rounded shape, and also that rounded shape into a triangle. These type of changes, the shape only can change but the continuity remains. This is nothing but the continuous deformation in terms of topology. But there are some restrictions related to continuous deformation. One is nothing but there would be no tearing of that object and there would be no gluing of that object. That means we cannot tear an object to make the new object, or we cannot glue some objects to make the new object. This is nothing but the structure preserving of topology. For example, you can take a coffee mug which can be continuously changed into a donut shape. We can observe that the coffee mug has only one hole and the donut also has one hole. So mathematically speaking, that these two objects, that means a coffee mug and a donut, they are the same. That's why mathematicians called these coffee mug and donut are equivalent in topology. So here are some examples. If we can take a sphere and a torus. Sphere has no holes, and the torus, which means the shape of a donut, which has only one hole. These two are not equivalent because the number of holes in sphere and the number of holes in torus are not the same. So mathematically speaking, in topology these two objects are not equivalent. So you can take another example. These are the four examples of topology. The first one is sphere. It is of genus 0. We can say that genus means the number of holes present on that object. Second one is the donut shape, which has only one hole. That's why it is called genus 1. The second one, which is genus 2, which has two holes. The fourth object is genus 3 object, which has 3 holes. What are the applications of topology? Have you ever think that these topological statements and objects that can be subject to the real life examples? First one is subway network, and the second one is internet network. How was the internet arranged? And we can able to study the DNA structures using this topology, and also the neural networks which are working in our brain. This can also be subject to topological structures. So topology begins with a simple question, which is nothing but what remains unchanged when the shape changes. There are some allowed things and there are also some not allowed things. The allowed things are you can able to compress it, you can stretch it, or you can bend it, and you can also twist it. But you cannot tear it or glue it to make the new objects. This is nothing but the continuous deformation in topology. This topology question, that is what remains unchanged when the shape changes, leads to a new branch of mathematics that is nothing but topology. Here are some examples of topology branches, that is general topology, algebraic topology, geometric and differential topology. These are some branches of topology. So this is the introduction video, and we can do some video series where we can able to explain the topological objects visually and also theoretically. So thank you for watching this video. Kindly support our channel, which is Path and Math. A like and share and subscribe will be give me boost to get more content.